So here at the Texas Advanced Computing Center, we provide large-scale computing resources to open science researchers around the United States and around the world, particularly around some of the bigger instruments in the world, the Large Hadron Collider, LIGO, the Laser Interferometer Gravitational Wave Observatory. We have users from about 400 universities around the US and from another 60 countries around the world. Traditionally, we've worked mostly with engineering, chemistry, physics, astronomy, material science, the sort of simulation-driven fields. Now in the age of data and artificial intelligence, if it's something that a university researches, we're probably part of the solution, whether it's self-driving cars or autonomous vehicles or bringing together large amounts of data from networks of sensors. It's hard to pick a field of science that is not computational in some way or other at this point. A lot of what we do in building supercomputers and a lot of what distinguishes them from the commercial cloud is how we interconnect them. When we want to solve one really large problem across a whole bunch of those commercial processors, we need a very low latency and high bandwidth way to hook them together. We picked InfiniBand because latency is such a huge driver in system performance, and it matters more and more as we get to larger and larger scale. We can get from processors in the rack to another processor in the same rack in less than a microsecond. We can get across our entire machine of 100 cabinets in less than 2 microseconds. And if you're doing 6 or 7 million time steps, if you're modeling that hurricane every 30 seconds as it goes for days, then it's really hard to get performance if you don't scale the network along with the processor. So I think InfiniBand and our low latency approach to interconnect is what really sort of distinguishes our machine from just a bunch of servers in a commercial data center. Frankly, InfiniBand is by far the best that gives us these latency and bandwidth performance that we want. It beats everybody else. We've worked with Mellanox for more than 12 to 15 years now. I've actually lost track from Ranger, the machine that we did that was top 10 in the world in 2007, was our first sort of large-scale collaboration with Mellanox. I suspect we've done 12 to 15 large-scale machines, 3 or 4 that have been at or close to the top 10 in the world, including our latest machine, Frontera. What keeps me coming in is, one, knowing that we make a huge impact on science. And the other thing is we're doing it with some of the most technologically advanced tools in the world to run some of the largest computations in human history, to tackle the greatest challenges of our time. This is an easy one to be proud of.